decomposition reaction. Now, the reaction in which one single reactant break into two or more product. It is reverse or of combination reaction. That decomposition reaction is reverse of combination reaction, because in combination reaction two or more reactant combine to form single product, and in decomposition one single reactant break into two or more product. Now, based on under which condition decomposition takes place, there are three types of decomposition reaction. First one, thermal decomposition. Thermal decomposition. If decomposition reaction takes place in presence of heat energy, that decomposition take place in presence of heat energy. Now, different type of thermal decomposition reaction. Try to remember the general reaction. Under that general reaction, many examples are there. So, first one, metal carbonate on thermal decomposition produce metal oxide plus CO2. Metal carbonate on thermal decomposition produce metal oxide plus CO2. Example, CaCO3 on decomposition produce calcium oxide plus CO2. Magnesium carbonate on decomposition produce magnesium oxide plus CO2. Now remember, all metal carbonate except sodium carbonate, potassium carbonate does not undergo thermal decomposition. That sodium carbonate Na2CO3 heat, no reaction. It does not undergo thermal decomposition. Sodium carbonate as well as potassium carbonate. All other metal carbonate undergo decomposition. Next type, metal nitrate. Metal nitrate on thermal decomposition produce metal oxide plus NO2 plus O2. Example, now calcium nitrate on decomposition, thermal decomposition produce 2CaO plus 4NO2 plus O2. Magnesium nitrate, any metal nitrate you can take, magnesium nitrate, similarly it will give 2MgO plus 4NO2 plus O2. FeSO4, very common question in CBSE class 10, that what happened when we give FeSO4? Color of FeSO4 green. Now on heating, what happened? Ferric oxide plus SO2 plus SO3. It both produce SO2 and SO3. Ferric oxide, SO2 plus SO3. All these are thermal decomposition. Next, that electrolysis. That means decomposition takes place when we pass electric current. Decomposition takes place when we pass electric current. That means in presence of electric current. First example, that water when we pass current through acid diluted water. Acid diluted water. That means in that sample of water you have to add few drop of acid. Why? Now water is a very weak electrolyte. So here few drop of acid act as a catalyst which increase the dissociation of water molecule. So acid diluted water, when we pass current, what happened? In cathode we will get 2 mole of hydrogen and in anode we will get oxygen. Why? Cation moves to cathode and anion moves to anode. So in cathode we will get hydrogen and in anode we will get oxygen. And that volume ratio is 2:1. That hydrogen is to oxygen, 2:1. Electrolysis of NaCl, molten NaCl. Because see that electrolytes only under aqueous condition or in molten condition conduct electricity. So we have to take molten NaCl. So in molten NaCl, if we pass electric current, what happened? In cathode we will get sodium and in anode we will get chlorine. So that is another example of electrolytic dissociation. Next, photochemical reaction or photochemical decomposition. That means decomposition reaction takes place in presence of sunlight. That decomposition take place in presence of sunlight. Example, most of the silver salt undergo photolytic decomposition. Most of the silver salt. If we take silver chloride, now sunlight we represent by H nu. Diffuse sunlight we represent by H nu. It is diffuse sunlight. We will get silver and chlorine. Now color change. That one white, AgCl white color, but that metallic silver gray color. So during that photolytic decomposition, color change takes place. That photolytic decomposition of AgBr, silver bromide. That one AgBr light yellow color. And that one grey color. And bromine reddish brown gas. Reddish brown gas.